Hello, everybody. How you doing there? Today we're going to be solving proportions. Now, just because I'm not here in person doesn't mean you shouldn't have paper and pencil out. So if you need to, pause the video, get out paper and pencil, make sure you're ready and prepared to try out these problems and answer them to the best of your ability. By the end of the day, you'll be able to find the missing part of equivalent proportions. Okay? You'll accomplish this by solving the equations. We're going to be treating this as if we are solving equations. Now let's start with a more intuitive proportion to solve, okay? So I want you to think about this. What value of n here will make these two ratios equivalent? What value of n will make these proportional? Now, a lot of students, and of course we can't have a discussion about this because I am not there with you, but discussions I've had in the past is students notice that, well, if we take 6 and divide it by 2, that gives me 3. So I know that 12 divided by 2 will make n equal to 6. Students notice that 3 is half of 6, so n must be half of 12. Okay, another way you could think of this is, well, 6 times 2 would give me 12. So 3 times 2 would give me 6. So there's a few ways that we can look at proportional relationships like this to find the missing piece. Okay, this is one like intuitive way we can do it. So here's another example where we can see a pattern here. 16 times 3 is 48. Okay, 16 times 3 is 48. So we're just going to take 3 times 3 to get 9. Right? So z is equal to 9. Now this method and this strategy is great. We'll see in a little bit that it doesn't always work out to be so nice and neat. And what do we do then? Go ahead and practice this one. Hopefully you recognized that we could multiply the 1 times 3 to get 3 on the bottom. And so we're going to multiply times 3 across the top, and we see that p is equal to 6. Again, this way is nice. The strategy works. It's great, but it's not going to work with all of our proportions. Like this one, for example. If we look at this one, there's no clear number that we're going to multiply 9 by to get 12. There's no clear number that we're going to multiply 12 by to get q. So what we're going to do is we're going to solve this as an equation. Now, one issue that I have with solving this as an equation is that my variable is in the denominator. Okay? I'm going to take the reciprocal of both sides, which just means I'm going to flip both of my fractions. So this is q over 12 now is equal to 12 over 9. I want my variable to be in the numerator because it makes it a lot easier to solve this equation. Now to solve this equation, this is q divided by 12 is equal to 12 divided by 9. And we're just going to isolate this variable, just as we've been doing with solving equations. Q divided by 12, how do we undo division? We undo division by multiplication. So we're going to multiply this side by 12, and if we multiply the left side by 12, we must multiply the right side by 12. You'll see 12 times q gives me 12q, and 1 times 12 gives me 12. There, that 12 over 12 is going to create that 1q. And on the right side here, we get 144 divided by 9. 144, 12 times 12 is 144 9 times 1 is 9. Again, you're welcome to use a calculator on this, but you'll find that 144 divided by 9 is 16. So Q is equal to 16. So again, in this example, we couldn't use the strategy of looking at what are we multiplying here. We can't find Q intuitively, but we can use our equation solving skills to find the value of Q. I started by flipping both of these fractions, taking the reciprocal of both of those fractions so that my variable is on the top, and then I'm just multiplying both sides by 12 to undo this Q divided by 12. Go ahead and try this one. Now, the first thing you should have done is to flip this fraction, because it becomes very difficult to solve an equation if our variable is in the denominator. So I'm going to flip this side, take the reciprocal of this side. As long as I take the reciprocal of this side, everything should work out fine. This is f divided by 28, so to undo f divided by 28, I'm going to multiply by 28. If I multiply the right side by 28, I need to multiply the left side by 28. These are going to reduce down, right? I'm going to be left with f on the right side, and let's see what we end up over here. 28 times 14. We get 392, and 1 times 8 is 8. Dividing by 8, we get 49. I'm using a calculator on this. You should use a calculator as well. Now you can reduce this ahead of time, okay, which some students like to do, okay? Looking at well, first of all, 14 over 8 can be reduced, or you can, right, that'd be 7, that would be 4, and then we can reduce this even further. This would be 1 and 7, right? So if you know what I'm doing there, you can also approach these problems like that so that you don't end up with such giant numbers. And in the end, we'd have 7 times 7, which is 49. All right, as you progress in the skill, the numbers just get bigger, okay? So don't be afraid to use a calculator. When you see large numbers like this, don't be afraid to use a calculator. I encourage you to. I don't expect you to do this long multiplication and long division. That's not what I'm testing you on here, okay? So this time it's nice that the variable is in the numerator. So now all we're going to do is multiply by that denominator. How do we undo 45? R divided by 45? We multiply by 45. And here's an example. We can reduce this down first. I see that both of these are divisible by 9. So that is 10 ninths. 9 and 45 are divisible. So that's 1 and 5. These reduce down, and we get that R is equal to, looks like 50. R equals 50. Now again, if you don't want to reduce down first, just use a calculator. We had 45 over 1 times 90 over 81. 45 times 90 is 4,050 divided by 81. We get 50, right? We should get the same thing. So again, this is kind of the calculator route. If you want to use a calculator, I'm fine with that. Or you can reduce as you go along, as I've done here. Go ahead and try. Oh, those are big numbers. Use a calculator, please! Exclamation point. All right, right, so to solve this, we're going to multiply both sides by 415. 415, 134 divided by 166 is equal to r over 415. We're going to multiply both sides by 415. Don't let the big numbers scare you. You've got a calculator. You've got old trusty Rusty right there next to you. Okay? These are going to reduce down. That leaves me with r. And I'll use old trusty Rusty this time. And we sing, oh, trusty Rusty, how I love you so. I love your precious buttons. I love the answers you show. And across the top, we get 55,610 divided by 166. And we find out that r is equal to 335. All right. Now you'll see some problems here that are word problems, okay? The next skill is word problems. All we have to do is take the information out of the word problems and set up our proportion. So as I'm reading this, I'm going to set up my proportion. So Kevin spent 42 minutes on the phone while routing 14 calls. So 42 minutes for 14 calls. If he routes 16 phone calls, so I'm going to we know the phone calls are on the denominator here. How much time will Kevin have spent on the phone total? So we're looking for how many minutes there. So notice I'm just reading through this and I'm setting up my proportion. And now we're just doing as we were doing in the last skill there. So I'm going to multiply both sides by 16. This is m divided by 16. To undo that division, we're going to multiply by 16. And we find out that 1m is equal to, and again, I'm going to use trusty Rusty here, 16 times 42 is equal to 672 divided by 14. 48. M is equal to 48. So 48 what? 48 minutes. Okay, so Kevin spent 48 minutes to make 16 calls. Go ahead and try this one. Set up your proportion and solve for the unknown. This one has Joseph jarring 20 liters of jam. Joseph jars jam. Do you jar jam? So Joseph jars 20 liters of jam in 2 days. So I set up that initial ratio. Okay, that ratio is going to help me find the missing information. How much jam did Joseph jar if Joseph could jar jam? What? How much jam could Joseph jar if Joseph could jar jam? Well, he spent 7 days doing it. So let's see how much he could jar in 7 days. All right, so we need to figure out how many liters, excuse me, that's liters. No, I didn't want to clear the whole thing. Okay, I'm back. I rewrote it. I'm going to leave it J. How much jam did he jar? I like J better than using L. You can use whatever you want. You can use X, Y, Z. So let's go ahead and figure out how many jams of jar Joseph jarred in 7 days. Well, Joseph jarred, let's find out. This is J divided by 7. So we're going to undo that by multiplying by 7. And these are going to reduce down. We're left with 1J over here. And on this side here, this will reduce down. We got 10 liters for every one, and we get 70 liters of jam. Joseph jarred 70 liters of jam in 7 days. That's a lot of jam, guys. All right, here's what you're up against. J13, J14. J13, I'm just looking for a score of 60. That is full credit. And J14, a score of 80. Have at it. Have fun. And when you're done, go jar some jam.